All right, we're going to look at the cell theory today. So, Tyler, cell theory notes. These are really, really quick. It's just something that I think is really important for you to know as we move on and talk about cells. So, write this down. About 400 years ago, scientists did not even know what cells were. That's really important. So, if you know that cells exist, even before we talk anything about cells, if you know nothing about them, you just know that they exist, then you're smarter than scientists were 400 years ago. So, that's really cool. There's this guy, write this down, Anton von Leeuwenhoek. He created a simple microscope. So, and it's really similar to the ones, well, it's not similar to it at all, actually, but it is sort of the springboard, I guess, for the microscope that we know today. So it was crazy looking. Look up a picture of that if you get time about Leeuwenhoek's microscope. It's crazy. Then there's this guy, write this down. He's really important. Robert Hooke. He observed cork under a microscope. And what cork is, if you know about like if you've ever seen like a wine bottle, the little thing, the stopper in the top is made out of cork. And basically, what that is sort of it's like wood. So it was wood is from a tree, right? Trees were alive, so the cork was alive or has cells in it. So they're just dead now. So what Robert Hooke did was he just looked at that under a microscope one day because that's how bored he was, and he saw little boxes there, and he said these boxes look like cells. I'm going to call these cells. The inspiration for that was because it sort of looked like a jail cell. So if you hate learning about cells, think about it as a jail cell. That's fine. I love it. So these other guys, Schleiden and Schwann, they discovered that plants and animals have cells. So Schleiden is responsible for plants. He's given credit for that. Schwann is responsible for figuring out that animals have cells. And the way that I remember that is Schwann sounds like swan, which is an animal. Schleiden doesn't sound like anything, so it's going to be a plant. The weird ways I remember things. So these two guys are important too. And this last guy who's really important to the cell theory is Rudolf Virchow, and he hypothesized that cells come from other cells. So he said, all right, I don't think that cells just appear. I think that they have to come from their own kind. So if a cell is born, we'll say, then it had to come from another cell. It's sort of like humans. We don't just appear, right? You come from other humans. Dogs don't just appear, they come from other dogs. Bacteria doesn't just appear, it comes from other bacteria, and so on. So he said, if all that's true, and we know that that's true, then I think it's the same for cells. Since cells, I have found, are in all these living things, or we have collectively found that cells are in all these living things. If it's alive, then it's going to reproduce more of its own kind. So here's the really, really crucial part. The other stuff was just mostly for fun. This is really important. Write all this down. There are 3 parts to the cell theory. Number 1, all organisms are made up of at least one cell. So if you are a living thing, and we just talked about that in characteristics of life, then you have at least one cell. Can you be alive with one cell? Yeah, most bacteria have one cell. Humans, can you have one cell? No. When you come together, you have 2. So next, number 2, the cell is the basic unit of organization in living things. So if you have a cell, it is organized. So if you have a cell, you're living. If you have a cell, it's going to be organized. That is how living things are organized, is based on the cell. And number 3, all cells come from pre-existing cells. Or in other words, cells don't just appear. They come from cells that were already there. So for example, and we'll talk about this a lot, if you get a scratch on your arm, say my kid is here running around, he scratches you, which he does sometimes, then that may leave a place on your arm. In 2 or 3 days, you look back, you can't even hardly see the scratch. That's because those skin cells that were like aggravated and caused to split apart, or maybe even flake off, they grew back, right? So skin cells replaced those skin cells that were removed. You didn't have an ear start growing back. You didn't have a kidney start growing back. It was the same type of cell. That's really important. I always say that every year. I say something like, if you get a scratch on your arm, you don't want like another heart to start growing. You don't want heart cells to be there. Some people think that would be cool to have a heart growing out of your arm. I don't. So you want the same type of cells or you want each certain type of cell to make the same kind of cell. So that way you don't get scratched one day and then all of a sudden have a liver growing out of your arm because your skin cells decide to take on the job of liver cells. That's never good. So even though some of you I know will think that's cool, it's not. It's not good. So that's it for the cell theory. I told you it was going to be really short and sweet. The people are important, but really concentrate on what the cell theory tells us. That's extremely important as we go on and we talk about cells and we talk about things like mitosis. So stay tuned. We will learn about all that and more as the year goes on.